Hello students, here there is a simple trick to find out bond order of a species having more than 20 electrons. That is, formula 1 is total number of bonds between any two atoms in all resonating structures by total number of resonance structures. That is formula 1. Then another formula is 1 plus total number of pi bonds by total number of sigma bonds. One more is there. Later we'll discuss in next video. F3 is based on bond order based on MOT molecular orbital theory. Its bond order is 1 by 2 into NB minus NA. This is for the species having less than 20 electrons. This is more than 20 electron, students. Now based on this, let us discuss one simple example, student. See here that simple example is I'll give like this. This is carbonate ion, students, CO3 minus 2. See here carbonate ion, one carbon central element and 3 oxygen atoms surrounded, and it forms like carbonate, 2 oxygen atoms minus 1 and 1 double bond is there. Now it is satisfied tetravalent. Central element is like this. These pi electrons shifted like this, then again immediately these negatively charged electrons are immediately donated to this. It forms a double bond. Like 3 resonating structures are formed. These are formula 1 is we know total number of see here total number of bonds between any two atoms. Total number of bonds like here in this species. Now here 1, 2, 3, 4 are there. Take between any two atoms in all resonating structures. In all resonating means either here or here, any one. In all these common are there, 4 are there. That's why F1 is 4 by 3, 1.33, students. Then follow the formula 2, second formula. Now 1 plus total number of pi bonds by total number of sigma bonds, students. Now see here, in this pi bond is only 1, sigma bonds 3 are there. Then 1 plus 1 by 3. So its answer is 1.33, students. Now clear? To find out bond order of species having electrons more than 20. Then see here, students, one more example. I'll give very simple example. This is O3 molecule, ozone. In first year chemical bonding, it is very clearly given, class 11th. Now in see here O3 molecule. In O3 molecule, 2 resonating structures are there. Now around these total number of bonds, how many? 3 are there. 1, 2, 3. Here also 1, 2, 3. That's why total number of bonds between any two atoms in all resonating structure according to formula 1 is 3 by total number of resonating structures, how many? 2. So its bond order is 1.5, students. Then apply the formula number 2, that is 1 plus number of pi bonds, how many? 1, divided by number of sigma bonds, how many? 2. Now this is 1 plus 0.5, 1 by 2 is nothing but that is 1.5, students. Now clear? Ozone molecule by using formula 1 and formula 2, 1.5 only, students. Now this is the second example. Now one more example, student. Now I'll take one more, a third example, that is sulfate ion, students. See here, sulfate ion, central element is sulfur. Around these 4 oxygen atoms are surrounded. Now here 1, 2, 3, 4, 5, 6 bonds are there total. Take any resonating structure. Total number of bonds are how many? According to formula 1, total number of bonds 4 are there. Now, sorry, 1, 2, 3, 4, 5, 6 are there, total number of bonds. Now, here how many resonating structures are there? See here, identify, students. 1, 2, 3, 4. Now divided by 4. So its answer is 1.5 according to this formula 1. Then see here, formula 2, by using formula 2. Now 1 plus number of pi bonds, how many are there here? 1, 2 pi bonds are there, students. This is the pi bond, this is the pi bond. Now 2 pi bonds divided by number of sigma bonds, how many, students? 1, 2, 3, 4 are there, students. 4. That is 1 plus 1 by 2, that is 1 plus 0.5 students, that is 1.5 students. Okay, clear students? Third example, sulfate ion, like one example is here carbon monoxide given, students. In carbon monoxide, actually carbon is 6 and oxygen is 8. Total number of electrons are many? 14 electrons, more than. So we can calculate by using bond order. Later we'll discuss about this, students. Then one more example, students. I'll give the one more simple example, that is about benzene. Here benzene, we know molecular formula is C6 and A6. Then its structure is like this. See here, symbolically here two resonating structures are there, Kekulé structures. Now we'll write like this. It is the complete structure of benzene, students. Now alternate double bond conjugated system exists here. Now around these bonds in this case, and one more is I'll take 6 carbon atoms. I'll write one more structure. Here double bond, single bond, double bond, single bond, like this. Here hydrogen, 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 and hydrogens. This is the complete structure of a benzene, one structural formula, resonating structural formula 1 and 2, Kekulé forms. So just identify the formula 1, students. According to this, number of resonating total number of bonds between any two atoms in all resonating structures means here double bond is there, here like a double bond is there, but here there is no double bond. See here, students, here total number of bonds are how many between these 1, 2, and here 1 is there, like 3 are there. So total number of bonds like this. Then 3 are there, divided by resonating structures are how many, students? 2. That's why its answer is 1.5 students. Then F2, according to this 1 plus number of see here how many number of in these number of pi bonds are how many? 1, 2, 3. 3 pi bonds are there. How many sigma bonds are there between? 1, 2, 3, 4, 5, 6 are there, students. Now 1 plus 1 by 2, students. That is nothing but 1.5 students. Like in this manner, we can easily to identify its bond order by using these two important tricks. If the species having more than 20 electrons, students. This is a very, very important trick to find out the bond order in objective examination without confusion. Hello, students. This is a very, very important trick to find out bond order based on MOT, molecular orbital theory. See here, students, based on MOT, molecular orbital theory, bond order BY is equals to 1 by 2 into NB minus NA. Here to find out bond order of any species containing less than 20 electrons, now compulsory we want one energy profile diagram. This is the energy profile diagram. Based on energy profile diagram, the species having less than 14 electrons and more than 14 electrons, that is up to 7 and above 7 atomic number elements, with the help of this energy profile diagram, then we can find out easily its bond order. But in objective examination, it is very difficult to find out its bond order by drawing all these energy profile diagrams. That's why there is one simple trick to find out its bond order. See here, that simple trick is in a given species, just identify the total number of electrons. If the species containing total number of electrons are 14, then its bond order is 3. Now based on this basic measurement, more than 14 electrons, 1 electron increases, its bond order 0.5 decreases. Then number of electrons decreases, more than less than 14 electrons, that is 13. 1 electron is less than 14 electrons, again its bond order decreased by 0.5. that is 2.5 like. So again one electron decreasing, 0.5 its bond order decreases. Approximately now number of electrons in a species 8 to 20 electron species, then easy to identify its bond order. Without wasting the time in examination, easy to identify the bond order of the species having less than 20 electrons. Students, okay? Now let us discuss one by one simple examples. First I will take one example. So here, helium molecule does not exist. Why? Helium molecule does not exist. Why? So here helium, it gives helium molecule. Here 2 electrons, here 2 electrons. Total 4 electrons are there. For this energy profile diagram is like this, increasing order of the energy profile diagram. Like number of electrons present in bonding molecular orbitals and number of electrons present in anti-bonding molecular orbitals are same. Now by using these total bond order is 0. That's why there is no bond between helium and helium. Only weak van der Waals forces are exist. That's why all the noble gases are monoatomic because its bond order is 0. Similarly, okay, for simple molecule easy to identify, but its atomic number increases, number of electrons increases, somewhat difficult to identify, and increasing order, decreasing order. They will ask a variety of questions. They will ask from chemical bonding based on molecular orbital theory based on bond order. See here, students, one simple example. Just created one heterodiatomic molecule, that is carbon monoxide. Here carbon monoxide containing how many electrons, students? Like 6 plus 8, 14 electron. See here table, 14 electrons means its bond order is how much, students? 3. Very simple to find out. In this manner, easy to find out its bond order. Now one more example, students, that is CN. See here, next example, next point, that is CN. Total number of electrons are how many here? Carbon 6 and nitrogen 7. 13 electrons are there. See this table, 13 means 2.5. It is very simple, very simple. See, I will give one more example, that is NO. Total number of electrons in NO 7 plus 8, 15 electrons. 15 means here 2.5 again. So in examination they will give which of the following molecular species having the same bond order as CN species, then NO, or any other related suitable example. We know this is a simple table, tricky table, then easy to identify its bond order. If they will give any model less than 20 electron containing species, bond order is easy to identify. See here one more example I will give. This is NO plus, means to this NO means from this NO 1 electron is removed, plus indicates 7 is nitrogen, then oxygen is 8, then from this 1 electron is removed, then again see here 7 plus 8 minus 1, 14 electrons, then 14 means its bond order is 3. Very simple, students. Then see here one more, dioxygen is there, O2. Total number of electrons how many? 8 plus 8, 16. Then its bond order is how much? Here 16 means 2 bond order. Then one more example. See here, Cn minus. Already here Cn given. This is Cn minus. 1 electron is added, students. Total number of electrons here 6 plus 7 plus 1, 14. 14 means again its bond order is 3. See here, bond order is 3. Then see here one more example. Very important example, students. This is based on oxygen, dioxygen. Here peroxide is there, peroxide ion, that is between oxygen single bond is exist. That's why its bond order is how much, students? Bond order is 1. 8 plus 8 minus 2 means 2 electrons are added, 18. See here in this table, 18 means what is its bond order is 1. Very simple example. See here one more is superoxide ion. Very important. Superoxide ion symbol is O2 minus 1. Total number of electrons are 8 plus 8. Minus 1 indicates 1 electron is added, 17. See here, 17 means its bond order is how much? 1.5. 1 point. It is a partial bond. Then again, see here one more example. Based on this dioxygen, peroxide and superoxide, they'll ask question like this. The correct order of bond order O2, O2 minus 1, O2 minus 2 is your increasing order given, like O2 minus 2, O2 minus 1, O2, your 1.1 calculated by using all these 1.5, 2.0 students. Clear, students? Then just identify this one simple card, simple table, just created one for nitrogen, N2 plus 1, N2 plus 2 and N2 minus 1, N2 minus 2. So increasing and decreasing order. Just identify, test yourself and